In this video, we will look at electrophilic aromatic substitution reactions of monosubstituted aromatic compounds. Some key ideas are some groups activate the ring, that is, makes the EAS reaction go faster, whereas other groups deactivate the ring, that is, make EAS go slower. The other key idea is that some groups direct the substitution in the ortho and para positions, whereas other groups direct the substitution in the meta position. For example, methyl benzoate undergoes Friedel-Crafts alkylation slower than phenyl acetate. The other thing is that methyl benzoate directs substitution in the meta position, whereas phenyl acetate directs it in the para position and ortho position. Here's another example. Aniline undergoes Friedel-Crafts alkylation faster than nitrobenzene. Note that the amine group directs the substitution in the para and ortho position, whereas the nitro group directs the substitution in the meta position. Experiments show that electron donating groups activates the pi electrons in the ring, that is, makes the EAS reaction go faster. It also shows that electron donating groups direct the substitution in the ortho and para position. For electron withdrawing groups, it deactivates the pi electrons in the ring, makes EAS go slower, and directs the EAS in the meta position. So here are some examples of electron donating groups, and here are some examples of electron withdrawing groups. This electron density map shows how the OH group donates electron density into the ring as shown in red. The other map shows how chlorine withdraws electron density from the ring as shown by the light red there. The methyl group is an electron donating group and directs EAS in the ortho and para position. So stop the video and draw resin structures for each intermediate. Identify the most stable resin structure, and that'll help you answer this question. Note that the ortho and para intermediates have a tertiary carbocation intermediate. These are much more stable than the secondary carbocation intermediates and the meta intermediates. The more stable intermediates direct the position of substitution, in this case ortho and para. We might expect the OH group to be electron withdrawing due to the electronegative O, but it turns out that the OH group is an electron donating group and strongly activating group. So stop the video and draw resin structures for each intermediate to explain why. So note that when we compare the ortho and para intermediates, we see 4 resin structures compared to only 3 for the meta intermediates. This tells us the ortho and para intermediates are much more stable. So atoms with lone pairs adjacent to the ring are electron donating and are ortho para directors. Other examples are the oxygen and alcohol, ether, ester, and nitrogen and amine in the amines. So why is the acid group an electron withdrawing group and a meta director? So stop the video and draw those resin structures to explain why. So note that we can draw 4 resin structures for the ortho and the para, but the problem is that note that there's 2 positive charges right next to each other in the para and the ortho. That's very unstable. So the more stable meta intermediates direct the position of the substitution. So a carbonyl carbon found in acids, aldehydes, ketones, and esters are electron withdrawing and meta directors. So let's practice drawing resin structures. So stop the video and identify each group as an ortho para director or a meta director. So here are the answers. And one limitation of the Friedel-Crafts alkylation reaction is that you get multiple substitutions. Note that the alkyl group is an activating group. If you're an older person who has allergies, you may have taken the antihistamine chlorpheniramine, also known as chlorotrimethane. So stop the video and identify the reaction conditions for this reaction. So the reaction conditions are Cl2 and AlCl3. And note that the R group is a ortho-para director. Okay, so practice makes perfect, so stop the video and predict the product of each reaction. Each reaction is a Freeland-Crafts alkylation reaction. So what you want to do is identify each group as a ortho-para director or meta-director. So here are the products. Hopefully you got 4 for 4, but if not, keep on practicing.